This video is going to be a review for test number 2 for Online Cal 1. So let me first begin by saying that for this test, remember this test is proctored, so if you have not scheduled a time to take your exam with the proctor, you need to do that ASAP. The test will close next Tuesday. I believe at least JC and JD, the testing center, is open on Saturday for a few hours, so you can schedule then on Saturday. If you cannot go to a proctor within the testing times, like to a testing center, then you will need to use the virtual proctor, and there is a fee. I don't remember what the cost is, but there is a fee to use the virtual proctor, and you have to have a webcam and such to do that. Alright, also, this is a proctored test once again, and so you will not have access to any websites, no access to any notes, nothing. So if you rely on those types of things to help you with your assignments, you need to make sure that you put the stuff in your head and so that you can rely on it from there. Alright? If you practice the problems, and for each problem you have to look at something to help you work the problem, you do not know it. Don't tell yourself you do, because you don't. You need to be able to look at a problem and say, what rule do I need to use to find this derivative? And then, how do I do that rule? Alright? I'm not sure. Let me look back at these notes. So you need to be able to work through the practice test without looking at anything. Not a single note, not an example, not a video, no questions from anyone, because none of that will be there on test day. And once you get there and you start testing and you realize that you don't have that stuff, then sometimes there's a little bit of a panic. So I would say go ahead now and start practicing with that practice test, and make sure you can work it without looking at anything. Okay? It just has to be in your head. Okay, with those things said, I first want to talk about, just look over the derivative rules. And so this sheet that you see on the screen now, has been loaded into Canvas, and it is under module that is named test number 2, and it is the very first document that says derivative rules. And so I just want to talk about those a little bit. Alright, if you're asked to find the derivative using a limit, this here is the definition. This is the limit process. When you see the limit as delta x approaches 0 of f of x plus delta x, this right here means to take x plus delta x, that whole entire thing, and plug it into x everywhere in the given function, and then subtract from it the original function divided by delta x. And you'll just have to go through, multiply everything out, and then combine like terms, simplify it down in some way. So I'll show you an example. For instance, if I have this problem here, find the slope of the tangent line to the curve of f of x equals x squared minus 2x at x equal negative 2. You're going to use the definition, so I would say the limit as delta x approaches 0, and I'm going to plug in x plus delta x in for this x and in for this x. That's the first thing you want to do. So I'm going to take the function, and so in place of this x, I'm going to put x plus delta x. That x is squared, so I'll leave that on there. Minus 2 times x plus delta x. All of that is over delta x. And then what I do is I go through here and I simplify it out in this manner. So make sure, if you were in a traditional class, face-to-face class, you would have to make sure that you always carry this limit as delta x approaches 0. That follows the problem until you finally make this substitution. Alright. So then when I square this is a binomial squared, so that'll give me x squared plus 2x delta x plus delta x squared. That comes from here. And if you want to multiply it out on your paper, then it would look like this, and then you would just FOIL it all out, and it would give you this. Alright, then here we have minus 2x minus 2 delta x, and I didn't put my own there, minus, I didn't leave enough room, and then this is where I put the entire function here, so minus x squared minus 2x. I don't know if you can see what that is, but that is the function itself. Alright, so this is where I plugged in x plus delta x, then I subtract that entire function, so that becomes minus x squared plus 2x. All of that is over delta x. Alright, then I just go through and I find anything that's alike, combine it together. Alright, the x squareds will cancel each other out. These two x's will cancel each other out. And then I can't combine any of those together, so I'm going to bring them over here. Get it situated here. Alright, so now I have 2x delta x plus delta x squared minus 2 delta x. That's what's left after I've simplified. Alright, all of these terms have in common a delta x. So I'm going to factor it out, or go through and divide everything by delta x, however you'd like to look at it. So I factored out my delta x from all of these terms on top. They all have one in common. Now this one and this one will cancel out. And I'll have this here. Of 2x plus delta x minus 2. Now when I plug in 0 for delta x, I don't have to write the limit part there. And so when I plug in 0 here, I'll have 2x plus 0 minus 2, which equals 2x minus 2. Now, if it's just asking for the slope of the tangent to the curve of this function, this would be your answer. Alright, but if it gives you an x value, if it wants to know at this x value, then you would plug it in, and -4 and -2 make -6. So if it just asks what's the slope of the tangent to the curve, this is your answer. If it wants to know at a specific point, you're going to plug into that to get your answer. Alright, now a short way that you could, once you've gone through this process to verify that your answer is correct here, is to use the derivative rules. And then I could come up here and I could say, what is the derivative? Right here. If I said, what is the derivative of this function, which remember is the exact same thing as the slope of the tangent to the curve. Right, derivative, slope of the tangent to the curve are the same things. So if I just took the derivative there, I would take, using the power rule, the derivative of x squared would be 2x, and then the derivative of -2x would be -2. Alright, so notice how this and this are the same, and they should be. Okay, so once you go through the limit definition, you can use this to verify that you have that correct, and then plug in your given value if they give you one. Okay? Alright, now the other rules that you'll need to know, let me get my paper sorted here. Alright, are going to be the derivative of a constant, so that's just, I'm looking for the derivative of a single number. Alright, that's going to be 0 always. So if f of x equaled 5, then the derivative would be 0. Alright, the next rule, and the rule you're going to use probably the most, the power rule, says if you have a single base raised to a power, you take that exponent, multiply it by the coefficient in front, then subtract 1 from that exponent. And we'll work through a couple of these. The sum and difference rule, if you have a function that has multiple terms being added or subtracted, so we could say f of x minus g of x. Right, all that would fit in here. Then there would be a minus sign there instead of a plus sign. But you just take each individual term and take its derivative. which would require power rule or constant rule. The product rule is if I have multiple things being multiplied together, so two or more things multiplied together, I'm going to take the derivative, alright, by taking the first function and multiplying it times the derivative of the second one. Then I add to that the second function times the derivative of the first one. Product rule. Alright, the quotient rule is when I have division going on, and that is you take the lower function and multiply it times the derivative of the top function. Subtract from that the top function times the derivative of the lower one, and then all of that is over the lower function squared. Okay, now make sure that you're always subtracting this part, because if you get these out of order and you subtract the wrong one, your signs are going to be off. Alright, you're going to get the wrong answer, so you always need to be subtracting top times the derivative of the lower. If you want to, maybe a way to remember this rule, you can maybe remember it as low d high, so low times the derivative of the high minus high d low. So top times the derivative of the bottom all over low squared. So low d high minus high d low over low squared, if that helps you remember that rule. Alright, and then the last rule is the chain rule. Well, not the last rule. The next rule is the chain rule. And it says if you have a function within a function, you first, then you could take a, you take the derivative of the main function, alright, and then take times the derivative of what's inside. So you kind of think of it as, first take the derivative of the mama, that's the main function, then take the derivative of her baby, that's the inner function, and I'll show you that as we go through it. Alright, the other derivative rules deal with trig functions. And so it's a lot easier to remember the trig functions if you kind of group them together. So if you kind of put sine and cosine together as a group, the derivative of sine is cosine, the derivative of sine, negative sine. So they kind of go together. And then if you put tangent and cotangent together, the derivative, if you can remember one, then if you kind of group them together, learn them as a group, it's a lot easier to remember the other. So the derivative of tangent is secant squared. The derivative of cotangent is cosecant, negative cosecant squared. If you put secant and cosecant together, the derivative of secant is secant x tangent x. If you can remember that one, it's a lot easier to remember cosecant, which is just cosecant x cotangent x. And there should be a negative sign there. So if you print your sheet out or you look at it, make sure you get you a negative sign in there. Okay, now these trig functions right here go for when it says sine of x. If it says any, or cosine of x, tangent x, cotangent x, cosecant, secant, if it says anything other than just x, okay, sine squared x, sine of 2x, sine of x squared plus 3, whatever it may say, alright, then you have to use these rules, the chain rule with trig functions, where you have, and these are, if you know the ones up here, then you can know the ones down here. It'll just be the derivative here, derivative of the main times the derivative of the inside. So the derivative of sine is cosine, and then take the derivative of whatever this is. So that's what's going to go on the outside, and I'll show you a couple of examples. Alright, I'm going to end this video with just the trig rules, and I'll in the next video we'll work through a couple of problems.